quicker than the texture of space-time can stay aware of it, it'll simply tear. I'm panicked by this right now. Our evening sky is changing quickly, and in a matter of many years, if not sooner, it may become totally unrecognizable. Cosmologists worldwide are sounding the alarm. Experts like Neil deGrasse Tyson have recently confirmed the upcoming explosion of Polaris, and the tale behind it is quite alarming. Polaris, known as the North Star, has long been a constant in our night sky, serving as an essential reference point for stargazers, pilots, and astronomers. However, this could soon change, altering our night sky and astronomical measurements forever. Let's dive into the significance of this threat and its implications for all of us. Join us as we uncover the story of Polaris as it approaches its end. For centuries, Polaris has guided sailors and stargazers alike, holding a revered position as a guiding light. Its steadfast presence in the night sky has been crucial for navigation. However, this stability may soon be disrupted. In September 2023, a research paper presented by the esteemed Royal Astronomical Society cast doubt on the fate of this celestial beacon. Polaris is on the brink of exploding, potentially vanishing from the night sky forever. Before we explore the consequences of this discovery, let's understand more about Polaris. Also known as the North Star or Pole Star, Polaris is unique due to its proximity to the celestial North Pole. Positioned almost directly above Earth's North Pole, it appears nearly stationary in the northern sky. Found in the constellation Ursa Minor, or the Little Dipper, Polaris shines as a relatively bright yellow-white supergiant star, much larger and more luminous than our Sun. It is not a solitary star, but part of a complex triple-star system, with Polaris A and Polaris B forming a binary pair, while Polaris B orbits around them. The interactions among these stars create gravitational forces that shape their orbits and influence their behavior. Any disturbances in these interactions can lead to irregular variations in the star's brightness or pulsation patterns. However, the precise mechanisms behind these interactions remain unclear. Polaris is located approximately 323 light-years from Earth, meaning the light we see from it today began its journey centuries ago. Thus, if Polaris were to explode now, we wouldn't observe it until over 300 years later. In fact, it is even possible that Polaris has already exploded, and we are yet to witness the light from that event. Throughout history, the North Star has held immense cultural, navigational, and symbolic significance. Its reliability and fixed position made it an invaluable guide for ancient sailors, directing them across seas and lands. Symbolically, Polaris represented stability and guidance, remaining steadfast amid the ever-changing night sky. For astronomers, Polaris has served as a crucial reference point, aiding in the study of celestial movements and variable stars. As a Cepheid variable star, its periodic fluctuations in brightness have provided valuable insights into stellar properties and the nature of variable stars. This characteristic has also played a key role in determining astronomical distances and calibrating instruments. These pulsations follow a predictable pattern, making it easy for scientists to anticipate its behavior. However, in recent years, Polaris has deviated from this expected pattern. This anomaly in its pulsation cycle has puzzled astronomers, leading to a closer examination of this celestial oddity. Instead of its usual predictable rhythm, Polaris has begun displaying irregular cycles of dimming and brightening. Scientists are now increasingly concerned that the star may be approaching the end of its life. This aligns with behaviors commonly observed in stars nearing their demise. The gradual elongation of Polaris' pulsation period, which was once steady, suggests significant changes within the star. Astronomers have observed an annual increase in the pulsation duration of 4.5 seconds. A seemingly minor change, but one with profound implications. Some scientists propose that gravitational interactions between the Polaris stars could be causing these fluctuations in its atmosphere, directly affecting its pulsation patterns. However, others are more alarmed, believing that similarities between Polaris and Betelgeuse suggest the star is on the verge of exploding. The parallels between Polaris behavior and that of Betelgeuse another prominent star in the Orion constellation, are striking. Both stars have exhibited mysterious irregularities in their luminosity, raising concerns about potential explosions. Stars in their final stages often display such inconsistencies before reaching the peak of their life cycles. While NASA has expressed heightened concern about Betelgeuse, similar attention has not yet been officially directed toward Polaris. As a Cepheid variable star approaches the end of its life cycle, it progresses through various stages, including the main sequence phase, red giant phase, and ultimately, a supernova explosion. Based on Polaris' irregular pulsations, scientists speculate that it has entered the helium depletion stages typical of Cepheid stars nearing their end. These anomalies in Polaris behavior align with patterns indicative of Cepheid stars in their twilight phases. However, definitive signs of its impending supernova remain uncertain. Astronomers are diligently analyzing these irregularities to determine Polaris' fate. If Polaris were to go supernova, it would likely be a breathtaking event in our sky, possibly outshining the moon and becoming one of the brightest objects visible for days, weeks, or even months. Its explosion could significantly alter our perception of familiar constellations like the Big Dipper or Ursa Minor, of which Polaris is a part. Rest assured, Earth would likely be completely safe even if Polaris were to explode, given its mass and distance from us. While a Polaris explosion might not be as visually dramatic as Betelgeuse's, it could still be visible to the naked eye for an extended period and outshine nearby stars. Astronomers and observatories would undoubtedly take notice, sparking interest within the scientific community and among stargazers worldwide. However, the specific visibility and impact on Earth's atmosphere or surroundings would be less significant compared to a closer supernova event. But what about Polaris itself? What will be its fate after a potential supernova event? Let's clarify one thing. While massive stars typically end their lives with a supernova, this is unlikely to be the case with Polaris. When a massive star goes supernova, an enormous explosion occurs within it, marking the final catastrophic phase of its life. This process involves a total collapse of the core, triggering an intense shock wave that causes the star to explode violently. However, Polaris is not massive enough to undergo such an explosion. Instead, when Polaris exhausts its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition will not result in a supernova, but rather a peaceful end, as it evolves into a small, yet extremely dense stellar remnant. The fate of Polaris and its impact on astronomy. While Polaris' ultimate fate as a white dwarf may not be as dramatic as a supernova, its disappearance or transformation will still have significant consequences for astronomy and navigation. For centuries, Polaris has been a crucial reference point for explorers, travelers, and astronomers. Its fixed position in the night sky has provided a reliable means of determining latitude and orientation. If Polaris dims significantly or disappears entirely, navigational systems relying on its position may need to be recalibrated. While modern GPS technology has largely replaced celestial navigation, the symbolic and historical importance of Polaris cannot be understated. The broader implications of a changing night sky. Polaris transformation is just one of many celestial events reshaping our night sky. Stars are not eternal. They are born, evolve, and eventually die, sometimes in spectacular cosmic explosions. The gradual but inevitable changes in the sky remind us that the universe is constantly in flux. If Polaris does undergo significant changes in brightness or visibility, future generations will look up at a night sky very different from the one we know today. Just as ancient civilizations relied on constellations that have since shifted or faded, we, too, will have to adapt to a dynamic and ever-evolving cosmos. Ongoing research and future observations. Astronomers around the world continue to monitor Polaris closely. Advanced telescopes and space observatories, such as the Hubble Space Telescope and upcoming missions like the James Webb Space Telescope, are providing deeper insights into the life cycles of stars. One of the primary goals of this research is to determine whether Polaris' unusual pulsations are a precursor to a major transformation or simply a temporary anomaly. By studying its behavior, scientists hope to refine their understanding of stellar evolution and the mechanisms that drive variable stars. What this means for humanity. While the potential dimming or disappearance of Polaris will not have any direct physical impact on Earth, it serves as a powerful reminder of our place in the universe. The cosmos is vast, ever-changing, and filled with mysteries that scientists are only beginning to unravel. Polaris' story is a testament to the dynamic nature of the universe. Stars, like all things, have life cycles, and their transformations shape the very fabric of the cosmos. As we continue to observe and study the night sky, we gain not only scientific knowledge, but also a deeper appreciation for the vast and wondrous universe we inhabit. Final thoughts. The idea that Polaris, our steadfast North Star, may one day change or vanish is both humbling and awe-inspiring. Whether it continues to shine for centuries or fades into astronomical history, its legacy will endure as a guiding light for explorers, scientists, and dreamers alike. As research continues, we may soon uncover definitive answers about Polaris' fate. Until then, we can look up at the night sky with wonder, knowing that the universe is alive with motion, mystery, and endless discovery. Cosmic explosion events provide important insights into the development of stars and their ultimate destinies. Contrasting our assumptions with legitimate supernovae like SN 1054 or SN 1987A, and later events such as SN 2011 Fe or SN 2014 J, gives significant information for understanding the possible consequences of Polaris explosion. SN 1054, for instance, resulted in the formation of the Crab Nebula, a cloud that continues to expand and emit radiation across various frequencies, offering astronomers a rich field for study. Similarly, SN 1987A, observed in the Large Magellanic Cloud, provided insights into the processes of nucleosynthesis and the dynamics of supernova remnants. Analyzing phenomena such as the formation of nebulae, the release of cosmic rays, and variations in luminosity can offer valuable knowledge about Polaris' unique characteristics. The formation of nebulae, like the Crab Nebula, results from the ejection of material during a supernova explosion, which interacts with surrounding interstellar gas and dust, enriching it with heavy elements and contributing to the cycle of stellar birth and death. Additionally, the release of cosmic rays, high-energy particles accelerated by supernova shock waves, has implications for astrophysical processes and cosmic radiation conditions. To make a conclusive analysis, researchers compared differences in mass, composition, and velocity of ejected materials between Polaris' expected burst and other observed events. This involves studying the light curves, spectra, and remnants of these explosions and predicting similar characteristics for Polaris' potential supernova. Assessing whether Polaris explosion could lead to the formation of nebulae or particular elemental distributions enhances our understanding of its possible outcomes. Another crucial area of research involves evaluating the pulsational variability of stars nearing their final stages, comparing Polaris with observed supernova progenitors. Such comparative analysis can help identify similarities or deviations, providing insights into the explosion mechanism. Pulsational variability in stars approaching the end of their lives may indicate internal instabilities or imminent catastrophic events, offering clues to the evolutionary processes leading to supernovae. Despite extensive observations and research, astronomers remain puzzled by the anomalies observed in Polaris behavior. Understanding the unique conditions driving these irregularities is key to advancing our knowledge of stellar evolution. Investigating the mechanisms responsible for Polaris' erratic pulsations requires interdisciplinary collaboration and the development of advanced theoretical models and observational techniques. The potential loss of Polaris as a critical reference point in the night sky presents significant concerns for astronomical research. Ground-based telescopes and celestial measurements would require recalibration, affecting the accuracy of astronomical assessments. The absence of Polaris could also impact navigation systems and cultural traditions that rely on celestial landmarks, highlighting the significance of this astronomical event. The complex behavior exhibited by Polaris underscores the importance of monitoring stellar phenomena and fostering collaboration to address questions surrounding star evolution. Polaris has long been our cosmic guidepost, but its eventual fate challenges our understanding of stars and their dramatic transformations. As astronomers continue to observe Polaris' unpredictable behavior, they grapple with the uncertainty of its future. While the idea of a supernova may seem like the most dramatic outcome for a star like Polaris, it's important to remember that not all massive stars end their lives this way. For a star to undergo a supernova, it must have sufficient mass, typically at least 8 times that of the Sun. Polaris, while massive, is not large enough to meet this threshold, meaning its final stages may unfold in a much quieter manner than previously imagined. Instead of exploding in a violent supernova, Polaris is more likely to undergo a transformation that is significantly less destructive. As it exhausts its nuclear fuel, Polaris will shed its outer layers and gradually cool and shrink, eventually becoming a white dwarf. This is a common fate for stars that are not massive enough to trigger a supernova. Over time, the white dwarf will continue to fade, and although it will no longer be visible to the naked eye, it will persist as a dense, compact remnant of its former self. However, this process, while not as visually spectacular as a supernova, still holds significant scientific importance. The transformation of stars like Polaris into white dwarfs is a fundamental part of the cosmic life cycle. The material ejected by the star during its shedding of outer layers will contribute to the interstellar medium, enriching it with heavy elements that can later be incorporated into new stars, planets, and even life forms. The loss of Polaris from the night sky would have profound implications, not only for astronomers but also for those who have relied on it for centuries for navigation. The North Star's fixed position has made it an essential reference point, particularly in the Northern Hemisphere, where it has been a guiding light for travelers, sailors, and explorers. For many, its disappearance would symbolize the loss of an anchor in the sky. However, astronomers and navigators have adapted to alternative celestial navigation methods, and while the absence of Polaris would be a notable change, humanity would adjust. Meanwhile, astronomers will continue to monitor the behavior of Polaris and similar stars. Advances in technology and the development of more precise instruments mean that we are better equipped than ever to track the subtle changes in these stars and predict their future behavior. The eventual fading of Polaris will serve as a reminder of the dynamic, ever-changing nature of the universe. Even the stars we once believed to be fixed and eternal have their own life cycles, periods of stability followed by dramatic transformations. The ongoing study of stars like Polaris also provides crucial insights into the broader mechanisms of stellar evolution. Understanding the processes that lead to the formation of white dwarfs, supernovae, and other remnants allows us to better comprehend the future of our own Sunday. Though the Sun will follow a different path, eventually becoming a red giant before shedding its outer layers and leaving behind a white dwarf, studying stars like Polaris helps us piece together the cosmic puzzle. As Polaris progresses through its evolutionary path, astronomers will closely observe its changing characteristics, refining our understanding of stellar life cycles. The insights gained from studying Polaris will contribute to broader astrophysical models, improving predictions about the fate of other similar stars. One key aspect of this research is the role of Polaris in the Cepheid variable class. As a Cepheid variable, Polaris exhibits periodic changes in brightness, which astronomers have used to measure cosmic distances. However, its pulsations have been irregular in recent years, hinting at underlying processes that are not yet fully understood. Continued monitoring of Polaris could reveal whether these irregularities are early signs of its transition to a later evolutionary stage or merely temporary fluctuations within its current phase. Additionally, the interaction between Polaris and its surrounding stellar environment remains an important area of study. If Polaris eventually sheds its outer layers in a less dramatic manner than a supernova, the material it releases will enrich the surrounding interstellar medium. This process influences the formation of new stars and planetary systems, contributing to the ongoing cycle of cosmic evolution. Beyond its scientific significance, The eventual fate of Polaris carries cultural and historical implications. Throughout history, civilizations across the Northern Hemisphere have relied on Polaris for navigation and timekeeping. Ancient sailors, explorers, and astronomers used its steadfast position to guide their journeys. And even today, it remains a symbol of direction and stability. Should Polaris fade from visibility over millennia, future generations will witness a celestial shift that alters the way we perceive the night sky. New navigational stars may take prominence, and astronomical catalogs will adjust accordingly. However, the knowledge gained from Polaris study will endure, providing a lasting legacy that informs our understanding of the universe. Looking forward, advances in observational technology, such as space telescopes, high-resolution spectroscopy, and long-term stellar monitoring programs, will enhance our ability to track Polaris evolution. By combining historical data with modern computational models, astronomers will refine their predictions about how Polaris' final stages will unfold. Ultimately, Polaris' journey is a testament to the ever-changing nature of the cosmos. Whether it quietly dims into a white dwarf or undergoes unexpected transformations, its story will remain an essential chapter in the study of stellar evolution. As astronomers continue their observations, they will unravel more mysteries of the universe, ensuring that even as Polaris light fades, its impact on science and human understanding will shine on.